We have a gentleman who has spent quite a bit of time in the games industry already. Majoritively at the time he spent has been done working with the game engine, improving the lighting and the level design layouts. For over 17 years, this has been one of his most focused areas of developments during his time within the industry, working on games such as like Dying Light, which was just released back in September. They're still working on that title, as you can imagine, for any kind of like updates and new areas of the games design that they're looking at. A lot of this work covers in atmospheric lighting and trying to make the most out of any assets once they're actually in the game engine itself. How do you do that? How do we process that way of being able to do that? As well as taking into consideration the elements of like passive storytelling. Remember, when we create level design, the idea is to encourage our players to get from the start of the level to the end and what they're going to experience during that time. So hopefully some of these questions that you might have about, you know, anything area related to level design and where to place your assets, what's the best place for spawn points, these are questions that may be relevant to you, that you'll always want to find out. This is what we're going to try and answer for you today. Most of the work as well that this gentleman looks at is about performance and optimization. Any of you who worked in the industry, or any of you that have done any work for us here at the university for quite a while now, know that we're always about improving the performance of the engine, improving the quality of the assets, sure, but we also need to improve the performance of the engine so we don't get any lag, so we don't get any screen tearing, you know, we keep our frame rates up and all that kind of stuff that's going on, as well as making sure that the player is ultimately engaged at all times and doesn't feel frustrated. So let me introduce to you a gentleman called Nickolaos Kasolos, and he's going to talk about all these topics for you and hopefully answer any of the questions they have. Nickolaos, please come and join us. Thank you very much. Yeah, man.
So yeah, I assume you can hear me. Hello to everyone. First of all, this is the first time I'm having a lecture like this one, so please bear with me. I'm sure we will get through this. And I'm here today with a lecture called Let There Be Light, a pipeline study for that impactful part of video games, which of course we called lighting. The idea is that we're going to break down the lighting pipeline from start to finish, mention all the major topics listed here, dwell more in some than others, and overall give you a holistic view what it is to be a lighting artist in the industry. Sorry. Yeah, but before that, a few words about myself. I'm Nick Kasolos. I'm working 17 years in this industry. I started at, no, sorry, I am currently I'm currently working as a lead lighting artist at Techland. Sorry, there is a fucking hair in my mouth. And it was attached in the mic. Yes, lovely. So yeah, starting over, I'm currently working as a lead lighting artist at Techland, and it's a company best known for the Dying Light franchise. But my journey started 17 years ago, and I passed through a few different companies. You can see them up there. And I started in a mixed role between level design, world building, which later translated to level art, and lighting. And very quickly, I dropped level design in order to focus in the more artistic roles. And even though at this point in my career, most of it has been into art managerial roles like lead artist and art director, I always choose to work on hands-on positions because at the end of the day, I love putting together content and lighting it. In that period, I worked in many different games and genres. I was unfortunate enough to have 7 of those being cancelled. I know that not everyone is advertising how many cancelled projects they have, but it's part of our industry. And, you know, we put time and effort into them, so why hide them? But then I was fortunate enough to have those 9 games released, and the latest one being Dying Light the Beast that we launched last September in great reviews from our community. Is a project that we're all proud of at the company, and I consider it as a personal high point. But yeah, we're not here to talk about me, we're here to talk about lighting. And the first thing to talk about is a bit brief history about the department as a department. Yeah, it took quite a while for it to be recognized as a department. It was initially handled from environment artists back in the day. In the early 2010s, it transitioned under level art. That's mainly when I came in as well. And only the last 10 years, we see it more and more as a standalone position. And that, of course, is due to how much the industry has ballooned, how every discipline is way more complex, it takes more time, and lighting is the same. It all depends on your team composition and the project scope. You might have a dedicated lighting artist, you might not. But the thing that you should always need to remember is that lighting needs to be planned and scoped on its own as its own discipline, because otherwise you're going to face problems down in the production. And why lighting matters overall in our industry? First of all, it's very important for the final image, the final thing that the players see. We influence atmosphere, we influence visual identity, we help with player path finding and guidance, and we're very, very important for first impressions for our players, from your marketing material to the first hours that they're going to spend into your game. A well-lit game will always leave better impressions. And it's a role that has two sides. It's very artistic. Yes, we influence a lot the visual, but also we influence a lot performance. So a lot of our job is from one side to be creative, but also technical and optimize. A lot of it is optimization. And due to that duality of the role, when it comes to departmental friends, from one side we have level art and art direction. We work very closely with both. And from the other side, we have rendering and QA. Rendering because we cannot do with our rendering people. We love our rendering people. And QA because someone needs to tell us when we messed up. And they do that quite often. And before we move on, this started as a very brief point of what we're going to see in this presentation, but it turned into that very pretty message. Sorry about that. And it's this to say pretty much that the only constant thing in our industry is change and how often we need to adapt to it. From simply moving from one different project to the other, to new technologies making your pipelines obsolete, or simply enough, you change a company. You find a new studio and the new studio uses a tool that you don't. And of course, you don't want to scrap that position. You don't want to throw it out. Rather, you will adapt your skills and yourself in order to be able to apply to that studio. And early in my years, I was considered an Unreal fanboy, but only 3 of my projects got released in Unreal, 2 in Unity, and the other 4 in different proprietary game engines. And in all those situations, I was forced to adapt, learn those engines, transfer my skills. And all of that is to say that today we're going to see content from C engine, the engine that we use in the Dying Light franchise, an engine that excels overall for open world, full day night cycle games. But that shouldn't matter for you because we're going to focus on the fundamentals and the principles, and then you can take those and apply them to your project regardless of the engine you are using. So yeah, getting to the actual passes, we have global versus local pass, the 2 main lighting passes that we do. And they should be pretty self-explanatory from their name. But let's start first with global to bring everyone at the same speed. Global is for all those things that affect the level in a global or large-scale level. It has the usual suspects under it, like directional light, skylight, skybox, post-process, color grading, global fog. And from the other side, we have local lighting, which is for all those other areas, all those local points from the interior of a house to an exterior park to the interior of a moving vehicle. All of those will be considered local. And local has all the fixtures under it, all those sources, from candles, lamps, even bioluminescent plants, and so on. And we also, under local, have local post-process and local fog for all those times we need to deviate from global. And of course, we also have ambient pass, something that is important enough to have its own section into this presentation. So we'll explain more about it in a bit. Here is an example. This is from the Beast, and it's a location lit only with global at night. And the same location, we also add local lighting into it. So we have those two working together. And then another night example, this house, again, right now lit only with global. It's dark because that's the nights in Dying Light, dark and scary. And that's with local being added to it. So those passes interact with each other a lot. And we need to explain a few facts about each of them. First of all, yes, you can light together global and local. You can do both passes at the same time into your location, but you should not track them together. You should track them separately. Global is one thing, local is another. Global is very important. It sets always the states. It influences a lot of things, and we're gonna go into it in a bit. Global pass also is shared. Think for all those locations that you have one global pass, but many individual local locations. Global will be one, local will be many. So then also we have local only locations. Think the interior of a cave, for example, or of a house that never sees outside. Those will be local only places. And local tends to be the most intense, time consuming, artistic, and the pass that needs the most optimization afterwards from the two. So it's not surprised that it takes most of the part of this presentation as well. So the idea is that we're gonna dwell in a bit more for each of those passes, and mentioning some important things, starting with global. And we said global sets the states, but why, right? Global has so many things under it that, like directional, post-process, color grading, and so on, exposure, of course. And all of those affect our color scheme and affect our luminosity curve. And it's only natural that all the assets that all other departments are doing, like characters, VFX, environment, they're all affected by the choices that we take into our global pass. And also local, of course, is affected. To the examples that you saw before, whatever we do in local, all those values are relevant to what the global used. So those values on local do not stand, in nothingness. They always based on global. Taking as an example the monastery here, we can choose to light it as a day, we can choose to light it as a sunset, or we can choose to light it as a night. And in all of those situations, it's different, and whatever asset we use, it depends on this light pass on how it's going to be presented to our players. Here another example, this lovely guy, he was lit on the left, that's how he was intended to look like, and that is a combination of both local and global. But on the second image on the right, just the global exposure is half. And now our guy is a bit too dark, and the local lights are not enough, though all those local lights will need to be adapted in order to work with the new exposure. So again, whatever we do in global, it affects local. So if global is that important, how do we deal with it, right? And it's honestly a matter and subject of organization and planning. Initially, we need to establish global standards early in production. Leaving pre-pro and ideally maximum until vertical slice, we should set ranges of how bright our sun will get, how bright our skybox will get, what are our exposure ranges for the project, and then simply we're going to use all of this as the baseline for the whole project. Then these few topics will also apply to local, but we're talking about global here. And the thing is that you should always you should break down those passes into two steps each. We have some crazy names called first pass and second pass. And yes, that means that global will have 2 passes, local will have 2 passes. That's 4 of them to track. Of course, you can work all the first ones together and all the second ones together. And the idea is that you're going to do the first pass before alpha. You're going to light the thing and then give time for the other departments to use that global pass, to use what you did there and base their work into your work. And then on the first one is where you're going to also bring creativity. That's where you're going to decide how much you will deviate from the global standards that you set. And at this point, you will make the location feel unique and why it matters on its own. And then you're going to have a second pass, and the second pass comes after alpha towards beta. And at that point, other departments have worked with the same content. So you come back in order to finalize your work and adapt it to all the changes that other people have done. And it's the thing is that, you know, in our industry, we want to finalize something always, but that never happens. Everything can change at any point in production. And late changes in global can affect all departments, not just yours. So please, for all those situations, make sure that you give enough heads up to all departments, because no one likes to be blindsided for the work from others. So next, color grading, love and hate relationship with color grading, because it's a very powerful tool. Every like color grading can color shift everything that we have, and it can change the luminosity curve to whatever we need it to be. And the thing is that late production in changes in color grading in games does not work well overall. And I'll explain why. Initially, color grading is a shared responsibility thing. Lighting owns the technical and implementation side of it. And then we have art direction for approval and overall the vision. Those two work really close together to achieve the color grading that we need for the project. And how good color grading will be, if we take as an example color shifting, it depends on the baseline. We need to be consistent with how we light. For example, all fires to be of the same color, all alarm lamps to be of the same color. And this way, when we color shift, we're going to get expected results. So on global, doing color grading changes like that, it works. But for luminosity curve, it doesn't. We have the situation where, you know, you cannot change the darks and brights of your whole project at late production and expect that every local location will work. That never happens. You're bound to break something. So global color grading changes should be contained, let's say, to colors. And please do local changes then if you need to do for your luminosity curve. And late stage stability always comes first. So, you know, the last few months of your project, do not go and change everything dramatically. It will break work from many people. So simply put, just stay in an unwritten rule of 5 to 10% difference from the original values for everything that you change with color grading. And that should be a safe enough space to not affect the other people work too much. And the last thing for global is physical-based lighting. There is a thing where we can use real-world values for global assets like directional light, sky, and exposure. And by taking real-world values, we take some of the guessing game out, and we can get some nice-looking results very quickly. It's a method that works quite well if you aim for photorealism, but also it works with other art styles. If not mistaken, Fortnite, Sea of Thieves, and many other stylized games are using this type of method. And there is a version of it where you use physically based global, but non-physical local. And that is actually my favorite because local tends to be more creative. And when it comes to physically based, it tends to be more technical, not as creative. So using a combination of these two, you can get, in my opinion, the best results. This is a topic that honestly could be its own lecture, so we need to move on, but I will leave you with this video here from Camille Yasser, and he takes this exact location that you see and he relights it from zero with a global path that is physically based in Unreal, and he shows also all the sources that he gets all the real world values. It's a great starting point if you want to learn more about this subject. So, moving to local, the more time-consuming part, and the best part to start in local is this. The slide that took me the most amount of time to put together, as you can imagine. The ideal starting point is a black blank canvas where we can just control everything lighting-wise and then use the additive method to go from large light sources and important light sources to the smaller ones. You should always ideally have this, but that is not sadly always achievable. We just talked about global, and then you can have a situation where you have global lighting, but then you cannot change it for that local location. So this is unattainable in that example. So in those cases, you should simply incorporate what you cannot change into your local path. But ideally, if you can get this, be happy, you have more creative control. And moving to light fixtures, because of course, when we place lights, we need something to cast those lights, and it all starts with the fixtures themselves. And first thing to talk about is that spatial directionality always matters. Take as an example a room that we have multiple lights coming from the ceiling. All those lights should be of the same type and the same color. And at the same time in the room, if we have different lights, let's say in the walls, ideally they should be of different type and different colors. And this way we can have the ones be complementary to the other. And it helps us set consistency. And for lighting, we're looking a lot for consistency because then we have the power to break it when we need to do it for emphasis. And consistency matters a lot for the next, which is everything that can be lit, it should be lit. If something is emissive, please light it. If you cannot light it for reasons, then consider it for it not to be emissive. This is a simple thing, again, for consistency. You know, if in our game have candle clusters, then if we light one of them, we need to light all of them. We need to teach to our player that when we see this asset, it's always consistently lit with a certain way. And we have exceptions for, sci-fi games, for example, have a lot of small emissive surfaces, and they're not very helpful to actually light them. But in most cases, you need to light whatever is emissive. Here is an example that we see with spatial directionality. We have a room with multiple colors. Of course, it has maybe too many colors, but still we can balance it with the logic of having a specific color and type based on where it comes from the room. So all the walls here are using this warm color. The one above the door is that blue, and something that comes even from higher up, which is an alarm lamp, it's that orange one. And they work all together because they have, like, let's say, spatial awareness. And next, light fixture distribution, because yes, we know what we're going to do with our fixtures, but how we place them. And I'm sure you have heard of this in other talks and in your books, but less is more, right? Do not overdo it. Stay simple. Use as fewer sources as you can. It's going to be better artistically. It's going to be better for your performance pass afterwards. And taking as an example, the only image I have here from Unreal, this is from Moon of Madness. And we have one source and multiple lights from that source, but it helps us create a more stronger image when we don't overdo it with too many light fixtures. And then the next thing is the thing that probably I need to make a tattoo out of some point. And it's negative space, and with me, negative space. Right? It's super important for everything artistic. We have it in real life. We have it in any type of media. And when it comes to lighting, negative space translates into the absence of light. It translates when we use very dim areas next to bright focal ones, and we use negative space in order to focus on our subject and properly balance content that uses a lot of negative space tends to look better and be more impressive. This image here, the reason that I like it is because it's drowning in negative space. And that negative space pumps up that bright focal point that we have. Negative space works with contrast, and as lighting artists, we live and breathe contrast. We always need to achieve it, and we use negative space to do it. So next, since we know all of this, okay, where do we start? What is the first thing we need to focus on? And the answer is always what the player needs to focus on. It's simple as that. We first light for gameplay. Lighting can be used as a very immersive form of signposting and player guidance. If the player needs to follow a certain path, and as this image here, it's way better to put lights to lead him there instead of using UI markers. It's way more immersive. And yes, we light for gameplay, but also we light for world building. We light for passive and active storytelling. And, that is for all those moments that you play in your games and then you turn a corner, you see something, it amazes you, and you stop to admire it. That is, well choreographed moments that a lot of departments put that together, and lighting comes in order to properly highlight it and pull the eyes of the player directly to it. Ideally, we light for both gameplay and world building, and those two align. And when they align, it's easier for us, but that not always happens. And when we have situations that those two, like for exaggeration, like gameplay points to the left and world building points to the right, then most of the situations, like 9 out of 10, we need to point to gameplay. And only point to world building when intentionally we want to misdirect our player. We don't point him then to the gameplay, we point him to world building, and that then, distracts them and it's easier to keep the player in a specific location like that. Here are two very simple examples, and I don't believe there is any doubt, right? Like where the player should go next from these screenshots. From the left, it's clear you need to go up the stairs because the lights tell you go up the stairs. And from the other one, we have the sun hitting specifically a tower. It hits also the zip line that gets you to that tower. So 100% the player in both cases will choose to go into these specific spots and figure out how to get there, at least for the second one. And I mean, it always looks better than putting UI markers. So use light for signposting overall. It's, well, better. And then we go to Ambient Pass. And to explain Ambient Pass, I need to explain light types first. And what we're going to talk about is per fixture. So every single source is not usually one light, it's multiple ones. And we start with the main light that you see as an example in this place here. There is one spotlight right now. Main light also is called key light. I tend to prefer the word main. So we have a main light that is either spotlight or rectangular light. It has the most intense shadows. It does usually the most volumetric scattering contribution. And it has the biggest coverage, right? Like it covers the most area. But main light alone is not enough. And then we add fill lights to it. And this is simple. It's a process that depends overall in the engine you are using. For example, in Unreal with Lumen, you will need less fill lights, but still you will need fill lights because this gives you the ability to direct exactly where your fill light can go. It's up to you. And we use mainly omnis, and we can use many fill lights for a specific source. And in order for them to be considered fill lights, they need to be sourceless. And to be sourceless, we should not have specular highlights and volumetric scattering to our fill lights. And this way we can use as many as we want and make them pass like they're coming from that one same light that we see. And the next thing that we add to this is an emission light. And emission lights tend to be one per light fixture. And the sole purpose of it is to highlight whatever is closest to where the fixture is attached to, the wall, the ceiling, the floor, wherever. And an emission light tends to be bright. It tends to be without volumetric scattering. And it's always one per fixture. Like we don't place more. So if I go back, this was just with one main light. And this is with all the lights together. And we do that for every single light. I did a color coding breakdown here so you can see the coverage, what each one does. And yes, because this is a small space, most of the work is done by the main light here, but it's more common in larger locations, the fill lights to do more of the work. So you will see more green in this example here. But you see how these interact. And yeah, we do that per fixture. So that means that we place a lot of lights everywhere around. And now that we know this, we need to talk about Ambient Pass. And the initial description might be a bit confusing. Ambient Pass is when we block the global lighting into a local location and then faking that global lighting with local lights. I know that is confusing. So we have an example to see. We have this barn here, and this barn right now is lit only with a global pass that is shared, so we cannot change for this specific local location. So I don't like how this looks, and I need to adjust it, and I will use an ambient pass to fix it. First of all, I would block the directional, even the sky if we need to, but often than not, the directional. And we block the directional with an invisible shadow-caster, a plane. We can do that in every engine. It's very easy to do. And the trick here for this to work is you need to block the directional with that shadow-caster, but not your local lights. In Unreal, you can do this with light channels, for example. And when we are at this point, we add a main light. And the main light, we control its coverage. We can make it look as pretty, as big, as small as we want. And from the main light, for the main light to work, it's important to have it, most of the situations, be clipped in the interior of the thing that we're lighting. And in Unreal, we can do that again with light channels. In CEngine, we have a way to clip lights into clipping boxes. So right now, we clip that light into the interior clipping box of the barn. And from there, we add fill lights. And we add, again, as many fill lights as we want. We control them, and we can get to this result from this. And yeah, it looks better. And, your players pass from one location most of the time just once. So make it as good as you can with an ambient pass. And this way, you don't need to change your global for a local location. And yeah, if you didn't guess it, again, it's a matter of control. For lighting, always we try to control every single thing that casts light into our scene. So we do ambient pass a lot to control our scene and control what is happening into it. And we already discussed about the coverage, that we can get way more coverage with an ambient pass. We can control it. It's a pipeline that helps a lot wherever we have a lot of interior and exterior transitions. Think open world games or like open-ended levels with a lot of local places, but just one global pass. It has a negative. If our game has full day-night cycle, that full day-night cycle needs to adapt to, I guess the ambient pass needs to adapt to it. And to do that, the thing that you can do is feed values from your directional to your local lights, either by feeding intensity, brightness, and directionality. That can be done from blueprints, code, and so on. And this way we can have our local update with the day-night cycle. And ambient pass tends to be a solution for total darkness, for all those situations that we cannot and should not have fixtures. We use ambient lights. We use a lot of fill lights to make a place have a baseline so the player can see at least something, even though the place supposedly is pitch black. And ambient pass is still part of local. We don't track it. We don't track it separately. And that means that you can have a location that has both. And it's part for the artist to decide which one will be the dominant one. And please make sure that you do not use both of them at the same intensity in terms of assets. One needs to have fewer assets because optimization will be a problem afterwards. And that is my not subtle way of segueing to our last topic, performance and optimization. For artists, that can be a pain. Optimization, we can destroy our work, just to squeeze out a few more FPS. But that doesn't have to be like that. Optimization can be fun and enjoyable if done right. And before we talk specifically for optimization, we need to cover a few things about performance. A few obvious stuff first. Performance is always project dependent. Some projects will be easier to optimize than others. It also depends on their genres. You need early on to decide what is going to be your target platform. It's very different if you aim for high-end PCs or if you're aiming for Xbox Series S. And you need to find your performance ranges early on in the project lifecycle. And the earliest you can do that is on vertical slice. When you work on your vertical slice, it's the first time that you have, in quotes, like final art and final gameplay. And simply at that point, you should exit with your optimization pipeline. And that's the one that you're going to use for the rest of the project. Please always remember, I'm sure you know this, but make a poster out of it and put it in your offices. Everything has a cost, right? Like some things are very shiny. They look very nice. Some features, we really want them in our project, but can we afford them cost-wise is the question. And there are going to be choices, like hard choices, that you're going to need to drop certain things due to their cost. And of course, there is such thing as too many plugins. We live in a day and age that third-party plugins from the asset stores are super easy to get. That's not a bad thing. You should use plugins. Some of them are amazing, but there is such thing as too many, and then they don't interact well together, and they end up being a bottleneck for your project. And always please consider using less. And also there is the possibility to replicate the functionality of a plugin in your project. And this way it's going to be more fitted to your project and more optimized. And of course, performance and optimization is a collective effort, right? Like everyone does their part, and a well-optimized game is a result of all departments working very well together. So now that these were generic for performance, we need to talk about specifically for lighting, shadows, right? The most clear one, we love shadows. We want them in every single light that we use, but that's not possible. Shadows are heavy. They up the draw count, they up the vertex count, they up the rendering time for the frame. So we need to be conservative with how we use shadows, and we do a lot of things in order to optimize shadows. Then, one light is okay. As many lights we add above it, we have overlap and overdraw, and we re-render pixels, and that tends to be problematic for performance. So we need to keep our overlap in check. And for lighting, we care a lot about the frame rendering time, how much time it takes to optimize the frame and to render the frame. And even though, yes, CPU calls the draw calls to the GPU, we care a lot how many milliseconds the GPU will take to render that specific frame. So we use that counter as a point pretty much to optimize. And I didn't mention them so far. Cutscenes, it's one of my favorite subjects for another time. But we have such thing as real-time cutscenes. It's the most common one in this day and age. And real-time cutscenes are playing above your content, your gameplay content. And that means that they share the optimization budget. And that tends to be problematic if you're trying to push lighting for both equally. So now that we know those 4 subjects, how we deal with them, and I try to keep those steps engine agnostic as much as possible. And we start with render distances because every engine has a render view distance for lights. So you can decide to call a light based on the distance from the camera. And in CEngine, we also have shadow render distance. This is something that you can even do in Unreal. I have seen it with my eyes. But of course you have to expose it. And the idea here is that you have a light that, let's say from 100 meters, above 100 meters is not rendered. Then from 100 to 50 is rendered without shadows. And then from 50 to 0, it's rendering with shadows. This way we can liberate a lot of our budget to use shadows, but render them only when we are very close to our player. And I have a very revolutionary method for light overlap. Learn the shortcut for the view preset for your engine. And I think it's Alt-7 for Unreal, I'm not sure. And spam it through your day. If you light, at least check the whole day, check at least 4 or 5 times your light overlap as you light. Don't leave it at the end, because you don't want to, at the end of the day, go back and destroy everything you did because the overlap is too much. Check it, keep it in check throughout the day, and then it's going to be a destructive thing. You're just going to work with it. And we have another a bit more tedious method of optimizing shadows and lights. And overall, it has to do with closing shadow casting on a per light and per asset concept. So, at the start, every light has shadows, but then we can simply take all the shadows from certain lights because at the end, they're not really contributing to our scene. And the same goes for assets. If we have this table here that casts shadows, everything under that table doesn't need to cast shadow. They're all drowning from the shadows of the table. So we can take them off and simply not have their cost. And from there, we need to talk about culling. And the most famous and useful, let's say, process of culling is occlusion culling, when we cull object based on the bounding box if it's seen from our camera. And that is not helpful for lights. Programmers and people will come to you and say, you need to make smaller lights. You need to reduce your radiuses. And no, man, like I cannot, because that's how this light looks so good. It needs to be that big in order to look good. So why should I make it smaller? And occlusion culling is not helpful for us. Instead, I suggest progression-based culling. So this is simple when your player is expected to pass in your level in a very specific way. Simply break the lighting of that level into chunks and then use volumes in order to trigger those chunks, render them and cull them. And this way, you can have everything that is not needed anymore being culled out. And of course, that helps with distance as well. That method is very useful for linear games, not as much for open world games. So for those, I suggest local culling volumes. And we did that in a project in Unity many years ago. And I loved it so much that I try to carry it in every project I have since then. And the idea is that we set up an actor where we add triggers, as many triggers as we want to it. And then we assign lights to it. So when the player is inside any of those triggers, we render those lights. It's simple as that. As an example, if we have a building, the building has multiple floors. If anyone has lit and tried to optimize a multi-floor building, you will know that it's a pain to hide and cull lights that are in the above floors due to bounding boxes. So we use this and make all the lights of the ground floor being one thing, and we render them only when we're close, and then we render the lights on the first floor when the player goes towards the first floor, and like that. We render and drop floors as the player progresses. This method is easy to set up. You can even do it with blueprints in Unreal. I did it very recently, actually, and it works quite nicely. And the thing is that it's a bit time-consuming to implement. Depending on how many local things you have, it can take some time to implement, but it's worth it because it gives you a lot of gains and a lot of space then to use lights locally. And for those cutscenes we mentioned, if your cutscenes are isolated with fade in and fade out, which is a common method to transition to a cutscene, then you can separate the cutscene lighting in its own sublevel and then put a copy of your local lighting from gameplay to that sublevel. So that means that you liberate the gameplay budget, and then you have the cutscene budget have a location path that you can alter as much as you want specifically for the cutscene. It can help a lot in those situations. And my last slide, and I promise the last pretty message, optimization is a habit, not a pass. And to show you how much I mean this, I have stopped tracking optimization in our backlogs and Jira for the whole content we have for like 7-8 years now. Instead, we optimize as we go. We optimize in our first pass. We optimize at the second pass. And the goal is when we submit something, already it has a first form of optimization. And when we finish our second passes, before we finish beta, at that point, we are done with the majority of the content. And you leave only the outliers, the worst of the worst been for the last few months of the project. As an example, Dying Light the Beast is a huge game. It has 800 plus dialogues and cutscenes and more than 1,000 local locations. And the last 2 months of the project, we had only 20-something optimization-related Jiras to do for 20-something locations. And most of them were simply a first pass, like another pass of optimization. And only 3 of them ended up being sticky and had the need to have more and more passes. If anyone knows the game, that freaking monastery, for example. And overall, doing it this way, optimization can be your friend. You can work with it quite well. And this way, it's not a destructive force that will come at the end of the production and mess up with your art. So yeah, that was it. Thank you for listening. I hope all of it was helpful. And if we have any time for questions, great. Otherwise, you can find me around here today.
Nikolai, thank you so much for that. That was some of the things that you were talking about there that I found incredibly interesting. Right from the very, very start, what I'd like to look at is that you your approach to that presentation there was more about understanding the process rather than the application itself.
Yeah.
So that's very, very interesting that you say this is how we look at developing the lighting that we need in these key areas. Responsible for player, what we want them to focus on, whereas be characters. Is there a preferred application that you've known that you said, I prefer Unreal or Unity, or is there something else that you think, when it comes to an engine, we prefer this one? Or what are your thoughts on the various engines?
If I'm going to use a public engine at this day and age, I would always choose Unreal. I like it as an engine. Yeah. But every engine has its benefits, and I'm not like a huge advocate of Unity, but no engine does better, for example, layers and prefabs than Unity, right? So every engine has its strong points, and the same goes for proprietary engines.
And the other thing that I did notice as well is that right at the very start of your presentation, there was a list of the games and titles that you've worked on, saying like there was 9 published titles. But next to that, there was 7 cancelled titles as well. Can you give us some insight as to why maybe some of those titles were cancelled?
Oh, yeah. Multiple reasons. So this day and age, it's a miracle if a game comes out, right? Most likely it's a game will be cancelled in production as we work because, funding tends to be an issue. Not finding the fun is another big issue because early on in production, we need to find, how fun is a game. We start working, we spend time, and then the fun never comes. And then, of course, you don't complete the game that is not fun to play. And there are always external factors that can affect. The sad thing is, you can have projects be canceled early in production, but also you can have a project be canceled like 2 months from release. Yeah. And that hurts a lot.
Yeah. I've seen that happen quite a bit. We had a game that we were working on called Wizardology. And the reason why it was cancelled was that the marketing team didn't know how to market it. Yeah. Because they couldn't wrap their heads around the gameplay and then how to, in that particular age of gaming, this kind of like gameplay style was not very popular and they still didn't know how to market it. Even though it had been around early on some very early PC games, they just said, no, we're going to have to abandon this particular game. And it was kind of like some of the people that I've also worked with where it's like, like you say, 2 months before release and they go, no, we're going to drop it. And there's like been years and years and years of like effort and work by the artists and the creators and all the management that's gone into it. And to see that project fall has been quite a shock. Do we have any questions from our audience, please? Yes, please.
Wait. Microphone. You good? Hello. Great presentation. I was wondering, are you also the one who's adjusting the specular levels on surfaces, and because how the light interacts with the environment is very down to the sort of the textures and the shaders in the environment as well? Right?
Yeah, correct. So every asset follows a certain pipeline for specularity and roughness. And on lights, then we have values in order to offset that and change it to what we need. But we have also situations where we use lights just for the specular highlight, and that works well for both environment and characters. I didn't mention that all, but specularity is a big thing of our work.
Thank you.
Anybody else?
When you're making an environment that is kind of dark and inside, how do you handle overlapping lights and stuff to make it light enough, but not be too hard on optimization and still have this moody feel?
If you were talking about situations that you do not have a visible light source, right?
No, you
ambient pass only.
You do have what I have been working on is an inside indoor laser tag arena. So there are natural lights, but it's supposed to be dark and moody. But there are also a lot of light sources, so it's hard to.
Dark and moody doesn't really mean no lighting, right? You can still have lighting, but not very intense. Play more with fill lights. And volumetric scattering always helps with moodiness and fog overall. And intentionally leave some parts dark, leave some parts, as we discussed, with negative space, and it will help in your transition and performance overall.
You can hi first. You talked about using like darkness and negative space to make a scene more like dramatic and stuff. But how would you make like a kind of outside scene on a more sunny day dramatic?
Strong sun, right? Like directional, like even in real life, you see a random building on its own is nothing, but then the sun hits it in a specific direction and it looks amazing. You take a photo. It's the same in games. Composition overall matters, your level composition, but then you can use strong sun, volumetrics from the sun, and distance and height fog overall to pump up the atmosphere.
Hi, thank you for the wonderful presentation. You have showcased us the examples of how to direct player towards where they should go. But what would be the examples of how to direct the player towards what they need to avoid, aka how to showcase the obstacles and the dangers on the level?
Depends. Do you want those obstacles to be visible to the player or you want them to be surprised by them? Because both are an option, right? So you can highlight the obstacles directly or then surprise them and have the obstacles in a dark area, they don't know about it and they fell into it. And so then, they learn out of experience, which is also a valuable point.
I know that hiding the obstacles in the darkness is the usual way to do it. But assuming a player is interacting with the level with like completely new kind of obstacles that they've never seen before, and they don't yet understand that what they're looking at is an obstacle, would there be a way to direct with light to make the player understand that this is dangerous?
I would highlight the obstacle then. Like, because flickering itself cannot really be used for that. You could, yes, add the light with flickering, but if it's an active obstacle that the player needs to learn about it, then that means that we need to teach him about that obstacle. So then highlight it. Find a way to bring the attention to that obstacle with light, and then, the player will do one and one.
All right, but how then do we explain the player that this is not the direction they're supposed to go in? Like, if we're using the highlights in order to direct the player through the level, how do we then separate that directional light from the this is an obstacle light?
So initially, you need to choose to do one of the two. Don't do both at the same place, right? Either point the next way or point where they should not go in order for them to find the next way. You can use colors. If your project has that design language, you can, put red alarming light towards the obstacle and then more positive lighting towards the correct thing. But try not to do both at the same spot. It can be disorienting.
Thank you. That was very helpful.
To an understanding of maybe the level design itself. I mean, if we have an area that we want to say, yeah, go down here, but we have something important that we want you to teach, we wouldn't really put the two in the same kind of like environment unless we specifically had to.
Yeah. So I'm sure this is mentioned overall. It's not specific to lighting, but the first thing that we do for every task is play the game, right? We need to always play the content. We need to understand what we're doing. And when it comes to lighting, I need to play the whole thing, figure out how the player got there, what he does there, and what happens to that place when the player leaves. And only when we know all of those things, we can actually start doing our work. So yes, in that scenario, you know what the player needs to do there, so you need to light towards that goal.
If we can go back a little bit further then, I mean, obviously your career has taken you down this path of level design and managing a huge team of employees to try and get all that kind of like work and development structure done. Where did you start? What was your breakout role and job within the industry?
So when I was in uni, I'm old, like we're doing Unreal 2. And that course it had art, design, and programming. And instead of following my lessons, I was building levels in Unreal to play them with all the other students in tournaments in the school. So that then landed me.
Been there, done that.
Yeah. That landed me the first job in the industry, and that was Aventurin, a company that, by the way, was half and half Norwegians and Greek people. And no joke, my first job was we had an open world where the terrain was happening in Max, and the objects were in Engine and nature and so on. So when the terrain changed in Max, the objects were floating. My first job was for 2 months to find those objects and snap them to the ground. It was ridiculous, and I was so excited that I had it because I was in the industry. And from that, the one brings the other.
Got it. Do we have any more questions from our audience?
Last one.
I'm wondering where you get your inspiration and references for your lights, if there's any specific place.
It's not one place. ArtStation, shows, movies, they all help. Real life helps. Lighting, I don't know if it's something specific to my experience, but it's one of those things that we don't get concepts. We don't get a concept for how something needs to be lit, so we need to figure it out. So we will put together mood boards, PureF or Miro, and overall we add to it from other games and movies, and that guides us. It also helps a lot play games. If you work in this industry, play games, see what other people are doing. It's always inspirational and helpful.
Thank you.
We got time for one more, or is that it?
More questions? Yeah, okay.
When in a project timeline should lights be considered? Pre-art, when you have something to interact with?
Sorry, I didn't understand. You mean when we should start lighting, or?
When should light be a consideration in a project? From the very beginning, or from some part when you already have some assets?
So yes, lighting can start in pre-pro, but there is no content to light in pre-pro, right? So we need level art and environment to have progressed for us to properly do something into the level. So that means that the first few months of the project, you're mostly doing research and examples and training. And the moment, usually vertical slice is the first thing that, okay, yes, amazing. Now we can light actual content. And from vertical slice, you go to alpha, so you don't stop overall at this level.
What about using some of the original concept art or the environmental design work that some of the artists have put together for you and how they've lit it? Do you follow that structure, or do you use that as maybe a starting jumping off point?
It can be helpful, but there is that situation where concept artists might do a concept not as a mood piece, but something as a guidance to people. So then we'll flat lit it pretty much. Thankfully, from our direction, we always get key art for the project and things that set the mood, and you have a lot of alignment meetings to get to that point. And then you also get references. Like people tell you, okay, we're going to use these 2 games and these 3 movies as a reference. Yeah. Go and watch them, talk about them, experience them, and it all adds up. And we do more than that, following a specific concept.
Thank you very much. Nickolaos, thank you very much for talking us through that entire area, and I've enjoyed it immensely. So please give it up. Thanks.